All right, we're going to look at writing an equation for this graph. Now, anytime we write an equation for a graph or a table, we need to find the unit rate, how things are changing per day or per month or whatever it is. So in this problem, we have the money depends on the number of days. So let's take a look at this graph. A lot of people, when they find the unit rate, they want to just go, oh, 1 day, and we're going to go straight up here and figure out how much money that is. Well, in this case, that's incorrect for a lot of reasons. If we go to 1 day and say, oh, 1 day is right here, so that's the unit rate, you're ignoring the fact that they started off with money. So we have to keep that in our minds, that they started with money. So they didn't earn all of this money right here in 1 day because they started with money. Another thing that's going on with this graph is when we go to 1 day, there isn't a clear point there. If I go over here, I'd have to estimate like what that amount of money is. So I'm not going to use the 1 when I'm finding my unit rate because I don't want to estimate what that value is. So I'm going to find a point on the graph where it's exact. For example, at 2 days, it is exactly $28. So I don't have to make any estimating. So I'm going to use that as my point. So we're going to look at, they started off between 8 and 12. So they started off with $10. And after 2 days, they now have $28. So that means that they earned $18. But it took them 2 days to do that. So they earned $18 in 2 days. Unit rate is per day, so we need to get it down to 1 day. And that means that they earn $9 in 1 day. Oops. So now when we write our equation, I always like to think of the initial value first. So when I write my equations, I like to start off with, does this person have any money to begin with? And the answer is yes. They have $10 to begin with because at 0 days, they already have $10. But they are gaining $9 every day, and that will be the total amount of money. So D is the number of days. M is total money. Nine is our unit rate. And 10 is our initial value. And that would be our equation. All right, we're going to look at one more graph. And again, we're going to start with finding the unit rate. So this graph is comparing the distance depends on the number of minutes. So I can see that it's starting at 0. So we're there. Now, again, we need a unit rate. If you go to 1, we don't know for sure where this is. So we can't estimate. We have to find a part of the graph where we can know for sure. Now, I see this dot. It looks like it's right in between 24 and 28. So I could be pretty sure that that's 26. But just to be really accurate and sure, I'm going to go to where a dot is right on the grid. So I'm going to go to this dot. Notice that this dot is right on the grid at 4 minutes is exactly 52. So I'm going to use that to find my unit rate. So for the distance, it went from 0 to 52. So it went up 52 meters. So 52 meters in, and now we have to see how long it took to do that. So in 4 minutes. To find a unit rate, we need to get down to 1 minute. So I will divide by 4. And 52 divided by 4 is 13. So they can do 13 meters in a minute. So I'm going to write my equation. I'm going to start by thinking about what my initial value is, what they start at. And in this problem, they start at 0. So there's no kind of starting distance. It just changes 13 meters every minute, and that will be our distance. So M is the number of minutes. D is the total distance. And 13 is our unit rate. And that would be our equation.